Alright, today we're going to be converting fractions to decimal, one of my favorite things to do. Now we're always going to start with something simple, like 3/4, so you can see how the process works. Then we'll make it a little bit more complicated. Remember that fractions are division problems. You just simply do 3 divided by 4. So if we're dividing by 4, that will go on the outside, and the 3 will go on the inside. Immediately you notice 4 can't go into 3. So we're going to put a decimal and add a 0. How many times will 4 go into 30? It'll go in there 7 times. We subtract and we get a 2. Well, there's something else there, so we have to add a 0. When we add a 0, we bring it down. And this time 4 will go into 20 5 times. 4 times 5 is 20. And that's the end of it. This one is what we call a terminating decimal. What terminating means is that it ends. It doesn't go on forever and ever. It terminates. Okay, so this one is a terminating decimal. In a few minutes we'll learn about repeating decimals. They don't end. So this is a terminating decimal. Our next problem is -5 7/8. Now, I know a lot of times we change these mixed numbers to impropers. This is not the time to do that. We can simply deal with the fraction first. So 8 will go into 7. We have to add a 0. So 8 goes into 7.0. Well, let's see. That would be 8 times, because 8 times 8 is 64. We subtract, and we get a 6 there, add a 0, bring it down. 8 goes into 60, 7 times. 8 times 7 is 56. Subtract. Oh, we're still going. Let's add another 0. And 8 goes into 40 5 times. Oh, look, it ends. It terminates, just like the last one. So let's look and see how we'll write our answer. We go back to the original problem, and we'll write -5. And then instead of the fraction, we are going to replace that with the decimal 875. Okay, so -5 7/8 is equal to -5.875. Okay, our next problem is -3 2/3. So just like the last problem, we're going to ignore the -3 and let's just deal with the 2/3. 3 will be on the outside, 2 will be on the inside. Now how many times will 3 go into 20? Well, that will be, what, 6 times? 3 times 6 is 18. We subtract. Oh, let's add another 0. Now this process of division should be familiar to you if you've passed the dividing decimals portion of our quizzes. Now 3 goes into 20 6 times. 3 times 6 is 18. Well, I'm noticing a pattern here. It's going to keep coming out 2. This is going to go on forever and ever. As a matter of fact, it'd be 0.666666666, as many sixes as you want to put on there. It goes on forever and ever. It keeps repeating. So my answer, I'm going to look up here. I'm going to use -3 because that was my whole number. But instead of 2/3, I'm going to replace it with a 0.6. Now watch what I do and draw a line over the 6. What does that mean? That 6 keeps repeating. That's why we call this one a repeating decimal. It's a repeating decimal. It means it repeats forever and ever and ever. Okay, so let's look at our last problem. 1 5 6. Now this one's going to be slightly different, but not a whole lot different. Just ignore the 1 for a second. Let's take the 6 outside, and let's put the 5 on the inside. Once again, putting down our decimal, and bring our decimal straight up. 6 will go into 50. Let's see, 8 times 6 is 48, so 8 times. We subtract. And we get a 2. So let's add a 0. And let's bring that 0 down because it doesn't help us if we don't use it. 6 goes into 20. 3 times. 6 times 3 is 18. So let's subtract, add another 0, bring it down. 6 goes into 20 3 times. And I think what we're doing is we're running that same situation we just had a minute ago, where it's going to keep repeating itself. So let's look at how we'll write our answer. We'll write 1 point, and now we're going to, instead of having 5, 6, we're going to replace it with a decimal. Well, in this case, it's going to be 8, 3, but what repeats? The 3 repeats. So we're going to put a line over the 3, and only the 3, because that's the only thing repeating. So that's fractions to decimals. Remember, you have terminating ones that end, and you have repeating ones that repeat forever and ever and ever.